Okay, in problem 1, it says given x cubed minus 5x squared minus 2x plus 10 equals 0, we're being asked kind of a set of questions. When you're actually asked this on a test, I'm not going to break all these different questions out. This is sort of leading you through the steps of really me just asking, what are all the solutions to this particular polynomial? Now, by asking you for all the possible rational roots, I'm kind of leading you to realize that this isn't going to be factorable, and we're going to make use of the rational root theorem, which is that P's and Q's thing that you've looked up. So when we're asked for all the possible rational roots, that's asking us for the list of P over Q's. So first I need to identify all the P's. Remember, the P's are the factors of the constant, so the positive 10. So if I'm thinking of the factors of positive 10, well, I've got positive 1 and positive 10 because that's a pair of factors. I have positive 2 and positive 5 because those multiply to make 10, and there really aren't any other pairs of factors. So those are all the possible P's. The possible Q's are the factors of the leading coefficient. Now, I don't see one, so I know that that's not 0x cubed because then I wouldn't have an x cubed term. That's 1x cubed. So all the possible Q's are just plus or minus 1. Those are the only things I can multiply together and get a positive 1. Okay, so the possible rational roots is the list of possible P over Q's. Well, we love it when Q is plus or minus 1 because when I divide plus or minus numbers by plus or minus 1, nothing really changes. I just end up with the list of possible P values. So my list of P over Q's is plus or minus 1, plus or minus 10, plus or minus 2, and plus or minus 5. That's the answer to the question. What are all the possible rational roots? At that point, it's not asking us to evaluate anything and find out if anything works. It's just saying, what are the possible things we would have to consider? Now, what are the rational roots? That's asking us for the actual ones. Which ones actually work? Now, back in the day when the rational root theorem was actually incredibly important to even being able to get an answer, we didn't have a graphing calculator to help us out. So there's a level at which I'm willing to let you cheat in these modern times of having a graphing calculator. And here's the level at which you are allowed to cheat. Now, this isn't really a cheat because it's being allowed, but it's a cheat compared to what we were allowed to do when I was learning this stuff in school. So we go to y1, and in y1, we're going to type the equation. And then from there, we're going to draw a super rough sketch. So let's pull up the graphing calculator and put in the equation. I'll clear out stuff from previous problems I was working on. And I'm going to go in here and I'm going to say, okay, the equation was x cubed minus 5x squared minus 2x plus 10. Now, I don't really know what's the best window, so I'm going to choose Zoom Standard. And I realize I can't see maxes and mins. I don't care about any of that in this problem. All I care about is what's happening around the x-axis. So when I look at this, I can see it looks like it's crossing between -2 and -1. It looks like it's crossing between 1 and 2. And it looks like it might actually be crossing on 5. So between -2 and -1, between 1 and 2, and between +5. So here's what I'm allowed to write on my paper. Between -2 and -1, between +1 and +2, and at 5. It looks like it's crossing through here. So I can draw that rough sketch on my picture. That's it. I now need to put the graphing calculator away and not touch it again. All right, rational roots would be any fraction type number. So it can be a whole number like 5, an integer like -2, or any number in between integers which can be written as a fraction. Well, if I suspect a nice whole number, I'm always going to try that first. So I'm going to take 5 and I'm going to use synthetic division to test and see if my gut instinct of it looks like it crosses at 5 is really true. So I'm going to do synthetic division here. And I see a remainder of 0. That's great news. That means 5 really is a rational root. Now, when I look at this, I'm like, well, it looks like it might have crossed between 1 and 2. So that would be a fraction between 1 and 2. And I look up at all the p's and q's. I don't even have any fractions on my list of possible rational roots. So this is the only number that was on my list of p over q's as being a possible rational root. I know I don't need to try any of those other numbers. They couldn't possibly be correct rational root. So x equals 5 is the only rational root. Now we're asked to find the factored form of the function. Well, I can do that using the rational root that I know about. If x equals 5 is a root, then x minus 5 must have been one of the factors. So my polynomial p of x includes the factor x minus 5, and then I can get my other factor from up here in my long division. That must have been x squared minus 2, and all of a sudden I can see why there aren't any other rational roots. X squared minus 2 is not factorable. Since it's not factorable, I couldn't possibly have any other rational roots. Now we're asked to go another step further. What are the irrational roots? Well, the irrational roots are going to come from that part that couldn't be factored. And using the zero product property, I know I can set that other factor equal to 0. If I add 2 to each side and then take the square root of each side, I can see that my irrational roots are plus or minus 2. And I've solved the problem.